Recording in progress.
Yeah, camera on. Let's start off. Yeah, so this was the last thing that we're doing. We started with the relative motion. Hope you remember how we started the whole story. So what is step one? So whenever you want to use relative motion, right? If there are more than 2-3 objects and they all are moving, relative motion is one of the best things to do. So step one, choose any observer with respect to whom you want to solve. Take that observer velocity, acceleration, subtract from everyone, including the object. Then the problem simply becomes, the observer will come to rest and everyone else velocities and accelerations will change. And from there, use regular kinematics and solve. That's what we have been doing. Let's do 1 or 2 more problems on this. So let's say we have a building here. Let's say height is 50 meters. We have a particle A here. This is projected with a speed of 20 meters per second. We have a point B here, which is projected with 30 meters per second. Both are projected at the same time along the same line. Same thing, 50 meters building. But this time point A is projected downwards with 20 meters per second. And B is projected up with 30 meters per second along the same line. So they're going to collide with each other. Find the time and the position where they collide. So two particles A and B are projected along the same vertical line. So case one, they're projected in the same direction, both are up. In the second case, both are projected in the opposite direction. Find the time and the position where they collide. There. Let's get them. 2 questions, 2 cases. Near Shreyansh. First one is wrong. Time is fine. Get the position also, Samyak. Near, yeah, time is wrong. Try 1 minute more, then I'll show you the first one. See, one thing is clear. I'm asking when they will collide, when will they meet. So I'm asking between two particles. So it is clear. It is relative motion based. So just stop any one of them. If you stop one of them, it becomes more easy to see the problem. You can stop any one, A or B. Right, Samyak. नहीं आ रही है. Right, Ishman. Let's see the first one. $50 meters. This guy is going with 30 meters per second. A is going with 20 meters per second. So step one, choose any one that you want. I will solve the problem with respect to B. So let's solve with respect to B. Now, when you solve with respect to B, you have to subtract B ka everything. But remember, there's also gravity here. Gravity is G, gravity is G. So subtract A ka velocity, B ka velocity. So I'll subtract 30 here. I'll subtract G here. So I'll subtract 30 here. I'll subtract G here. Isn't that what you're supposed to do? Subtract the acceleration and velocity of B from everyone. Then what will happen? The B will think, okay, I came to rest. And it will think this person A is coming towards me with 10 meters per second. And what is the acceleration? A relative is 0 because G got cancelled. Is that making sense? We wrote this thing last time, remember? A projectile will always think another projectile is going with constant velocity. A relative acceleration is 0. So in this case, B will think A is coming with a constant velocity. This is 50 meters. Therefore, we can simply find time is equal to 50 by 10. 5 seconds. Is that clear? So B will come to rest. A is going with constant speed and acceleration is 0. It feels like it is going with a constant velocity. Now, one thing is important. See, no matter which time, which frame you go, the time will always remain constant. So time taken to go from time is independent of the frames. Time taken for A and B to meet is independent of the frames. Means you stand on the ground, you stand somewhere, you do anything you want. The time taken for A and B will be same in all frames. So now get back to the ground frame. In all frames. So one thing is clear, they're going to meet in 5 seconds. So if you get back to the ground frame, means your observer is standing on the ground now. So this guy is your observer. So B is going with 30 meters per second. Gravity is G. So if you find the displacement of B, it is 30 into 5 plus half. Gravity is negative. A is negative minus G, 5 square. This will be 150 minus 125, 25 meters. Similarly, if you look at the displacement of A, the problem with the relative motion, right? It gives you the answers, but you lose all the information. You don't know exactly what is happening. This guy will be 20 into time plus half into minus 10 into 5 square. This will be minus 25 meters. So this is what is actually happening. This A is going up and it is coming down, right? And this B, while going up, this B also goes up. How much time will this take? 5 seconds, right? This time of flight will be 2 into 36 seconds. So this B is actually coming down already. And they collide here. So B goes up, and while coming down, this A is chasing from the back, and somewhere here they collide. This height will be 25 meters from the ground level. Is that making sense? So that is what is happening with the whole scenario. So A goes up and comes down. B also goes up and comes down. As B is coming down, A comes from the back and chases B and hits it. And they collide at the midpoint of the building. So if they ask you for the position, you can't do in the relative frame because everything is moving. You have to come back to the ground frame. So that is one thing you can remember. If someone asks you to find time, relative motion is the best. It saves you time. You can see instead of two particles moving, you made the whole problem into one particle moving. All got this? Now, can you do the second part? Same story. I just changed the velocity directions. Get it? I'll give you a minute. Yeah, right, Samyak. Get this, get this. What if both are in the opposite direction? So if you want to find time, use relative motion. But you want the position, you have to go back to the ground frame. Let's see. Yeah, time is 1 second and you'll get the same position again. Yeah, you'll still get 25.
Sir, but how is that possible?
If you wait till the end of the explanation, you might understand. So this guy, you're projecting down A with 20 meters per second. B is still going with 30 meters per second. Why this is not possible? This is the straightforward. They both are hitting head on. Same story. I can stop any one. This time let's stop A. I'll do with respect to A. So what should I do? I should subtract the A ka velocity. So 20 upward, G and G. So A will think, okay, I'm at rest. I'm not moving anymore. And A will think B is coming towards me with a speed of 50 meters per second. And what is the acceleration? 0. G got cancelled. What is the distance? 50 meters. So what is the time? 50 by 50, 1 second. Got this? Now go back to the ground frame. Now if you go back to the ground frame, in 1 second, how much will A will travel? Remember, A is going down, so minus 20 into 1 second, minus half G into 1 square, that is minus 25 meters. If you do the displacement for B, B is going up, so U is positive. Remember, up positive, down negative. Keep the convention simple. 30 into 1 minus half G into 1 square. This is plus 25 meters. Meaning the particle A in 1 second is traveling 25 meters down. That is the meaning of minus sign. The particle B is traveling 25 meters up in 1 second. That is the meaning of plus sign. They're colliding at the midpoint of the building. Arya, why this can't be possible?
Sir, then how will the bodies like collide for the first case?
The first case, though, told you, na?
Why
A is
did it
going
take
like
more
this.
time then?
अरे गॉड 30 seconds का इसका टाइम ऑफ फ्लाइट कितना होगा बताओ टाइम ऑफ एसेंट बताओ
Sir, it will be 3 seconds.
3
Oh, so
seconds,
it
but
will
collision
come
is happening
down.
at 5
Or
seconds. It is already coming down.
oh, so that's why.
That is how you check. Are you getting the second scenario, everyone? They will still collide at the midpoint. It came coincidentally. It is not a result of something. But that is how you do. Is everyone getting the relative motion thing? So if you want time, use relative motion. You want the position, come back to the ground frame. Any doubts on this? Right? It's a decent one. Let's see the next one. We have two buildings, H1, H2. Distance between the buildings is D. This particle is projecting with U1, theta 1. This particle is projecting with U2, theta 2. Gravity is there. So this guy will go something like this guy will go something like this. So the question is, find the minimum distance between them. So the first question is, find the minimum distance between them. So answer will come in terms of U1, U2, theta 1, theta 2, H1, H2, D, 7 variables. A simpler question would be this, find the condition if they collide. Yeah, that means minimum distance is 0. If the minimum distance becomes 0, that means they're colliding with each other. Okay, let's try this thing. I'll give 3-4 minutes. Yeah, one thing is clear. You're asking minimum distance, relative motion. If you stop one of them, one will come to rest and the other guy is going like this. So it becomes easy to observe. Difficult to study two parabolas. But if you stop one of them, yeah, that's at least better. Think. I'll give another minute or so. Let's call them A and let's call them B. The answer is not a good one. So I can't see you, right? Adjust your camera a bit. Let's study with respect to A. So step one, first of all, get the velocities. So A ka velocity will be U1 cos theta 1, U1 sine theta 1, u2 cos theta 2, u2 sine theta 2. Gravity G, gravity is G. So you decided to stop A, meaning I need to subtract A ka velocity from everyone. So I'll subtract u1 cos theta 1 from A. I'll subtract u1 sine theta 1A. That means you literally are adding it in the reverse direction. So I had to do the same thing. So I have to add them in the reverse direction. So I have to add u1 cos theta 1 to left for everyone. That is the meaning of subtracting. So u1 cos theta 1 I'll add like this, and u1 sine theta 1 I have to add it down. I had to add G also up, and I had to G also up. Yeah, this looks a little silly, and like we are doing with pictures, but once you get used to it, right, then you can maybe stop drawing so many pictures. You can directly write the relative velocities. But for now, for your understanding, I'm doing this. Now what will happen? So once you do this, A will think, okay, I came to rest. I'm not moving anymore. And B will think, my velocity has become in the upward direction. It is u2 sine theta 2 minus u1 sine theta 1. And this has become u1 cos theta 1 plus u2 cos theta 2. And what is my acceleration? A relative is 0. There is no gravity. Is this clear so far, everyone? That means now this B particle, now A will think B is going in a straight line like this. Because there is no acceleration, B will go in a straight line. Remember, it will not be a projectile anymore. So A will think B is going in a straight line. This red line is the path of A, path of B as seen by A. This is the advantage of relative motion. The acceleration goes off. And now you're asking a question, find the minimum distance between, what is the minimum distance between a point and a straight line? Perpendicular. This is your D minimum. Is that clear so far, everyone? And I can take this angle to be some alpha, where tan alpha will be the opposite thing. So u2 sine theta 2, that is a Vy by Vx. So this alpha will depend on the velocities. Numbers are given, I can calculate this alpha there. So I know alpha. Now what? So you have to get me the answer in terms of now h1, h2, and alpha. Now can you try? I'll give you a minute. Is the story clear so far? This is what A will think about B. A will think B is going in a line with a velocity, this vertical component, and that is a horizontal component, and with a zero acceleration. So that green line is your minimum distance. This distance is also there. Huh? This is D. Let's see. A little geometry. So this is point A. This is point B. This is distance D. So if I join the line A and B, let's call this angle beta. right? And how much will that be? This is H1 and this is H2. You can clearly see in the triangle tan beta will be the difference in heights H1 minus H2 by D. And here, this is your path of B as seen by A. And you got this angle is alpha. And you're trying to find this distance here. And from here, you can clearly see this angle will be alpha minus beta. And if I take this point as C, you can see ACB is a right angle triangle. You want to find AC, so AC is nothing but that is the opposite side here. So that will be AB sine alpha minus beta. Look at the triangle there. This is A, this is B, this is alpha minus B, and this is C. You want to find AC, that is the opposite side. So AC is nothing but AB sine alpha minus beta. What is AB? AB is nothing but, we can use the Pythagoras theorem, that is the triangle ka D square plus H1 minus H2 whole square. There I know AB also. I know alpha, I know beta. This is what I said, numbers are bad. So there, that's your minimum distance. AC is your minimum distance. So D minimum is AC, which is AB. AB ka value I know, which is sine alpha minus beta. I know alpha, I know beta. That'll be your answer. And if you want them to collide, alpha minus beta must be equal. For them to collide, sine alpha minus beta must become 0. D minimum is 0. Sine alpha minus beta is 0. Therefore, alpha is equal to beta. That kind of makes sense. Let me show you that if you want to do for the collision directly. If the question is find the condition for collision, don't do all this. This is a waste of time. That's actually much easier and faster. But have a look at the steps.
Sir,
It
I
might
didn't
look big and dangerous, but numbers are cannot be easy. Bolo.
I didn't understand this like last diagram you made of this geometrical thing with the H1 and H2.
This triangle, that one.
Yeah.
This one.
Huh. Oh no, wait.
What?
Wait,
Same thing. I just
Yeah.
wrote it. Matlab. If you're confused, maybe this height is H1 minus H2.
I
The
got
difference in
that
height,
now.
difference in height of the buildings.
Yeah, no, I wasn't viewing the two lines as buildings by the
Hmm.
way, so
You want buildings?
yeah.
They're buildings. There. All clear with this? So again, don't look at the problem and get scared. What is the whole point of the problem? Stop one of them. You'll start thinking the other one is going in a straight line. So something is going in a straight line, and if you are at rest, drop the perpendicular. That is the main in the problem. After that, everything is max only. Is that clear, everyone? Now, for the B part, you could have done it much faster. Ask yourself, if A and B wants to collide, what should happen? For A and B to collide, tell me one thing. If you want to come and meet me, you should walk which way? Let's say if I'm standing here and you're standing here, if you want to come and meet me, if you go like this, will you meet me?
No,
So you
sir.
should come and you should cross me, right? So that means when you stopped point A, when A came to rest, if the velocity of the B, if that path is passing through the point A, so if this was the path, that means they will collide, isn't it? The path of B should pass through point A. That is a D minimum is 0. So for them to collide, the path of B as seen by A must be along AB. So basically, indirectly, you made this angle alpha, you made this angle also beta. And just now we got that angle tan alpha is nothing but how much? This component here, which is u2 sine theta 2 minus u1 sine theta 1, all that story there. So this component will be u2 sine theta 2 minus u1 sine theta 1. And the horizontal component was u1 cos theta 1 plus u2 cos theta 2. And also from geometry, this height is h1 minus h2 and this distance is d. So both should satisfy at the same time. u2 sine theta 2 minus u1 sine theta 1, the vertical component, by u2 cos theta 2 plus u1 cos theta 1 should be equal to h1 minus h2 by d. So this is the condition for collision. If this condition satisfies, they'll always collide. This is much easier and faster. If they ask you minimum distance, yeah, you still have to do little working. But if they ask you the condition for collision, it is easy. Now from here, you can get all cases. If you put h1 and h2 both 0, means you are on the ground level. That means the condition is what? u2 sine theta 2 must be equal to u1 sine theta 1. So I can get all variations of problems. Other steps clear, everyone? Any
So
doubts on this?
could you explain why alpha is equal to beta once again?
What is alpha here? Alpha is the angle made by the path. What is beta? Angle between A and B. And if you're saying that a path should be along AB, means what? Alpha and beta are equal. Abhi prove kiya na? Clear? Now see, there is a vector form for collision. There's a condition in the form of vectors. This can be a theoretical question. This is the condition for collision for constant velocities, or when A relative is 0. Think of like this. Let's say we have a particle here. This is R1 bar. We have another particle here, B. This is R2 bar. And let's say this is going with velocity V1 bar, and let's say this is going with velocity V2 bar. And if they ask you this question, what is the condition these particles have to collide? Again, just now I told you, if two particles have to collide, how should they travel towards each other? Can we find minimum distance using slope point formula? I don't know. So what do you mean by that slope point formula? Can you brief? Utsa? Okay, let's see. You can ask me maybe after the class. So what is the condition for them to collide? You should come towards me, isn't it, to collide? So that means the relative velocity vector v1 bar minus v2 bar, this is your v relative. So let me write those things here. The relative velocity and the relative position vector must be opposite to each other. Relative velocity, relative position must be opposite to each other. Meaning it should look like this. So A and B is there. If this is your AB bar, then if you want to meet, the velocity must be this way. The velocity must be in the BA bar ka direction, isn't it? They both should be opposite, right? If they're in the same direction, what will happen? B will go away, they will never meet. The distance will keep increasing. So that means vectorially you can write like this. So VAB cap must be equal to R minus RAB cap. This is nothing but VA bar minus VB bar. So you want a unit vector of this, mod of VA minus VB. The directions must be opposite. This is minus of RA bar minus RB bar. by mod of RA bar minus RB bar. This is a vector condition for collision of two particles when A relative is 0. The relative velocity vector and the position vector must be opposite to each other, meaning the unit vectors must be opposite. Clear with this? That itself would be a theoretical question. They'll give like this: V1, V2, R1, R2. Find the condition for the particles to collide. I can just write this as VA, VB, RB, and this is RA.
So can you explain the part again where you said that why they must be opposite?
They're meeting regard. If you have to meet me, how will you travel? Will you travel towards me or away from me?
Towards.
So if you're traveling towards me, you're traveling opposite to the vector, right? The AB bar vector will keep decreasing. Clear? If your vector is AB bar this way and your velocity is this way, means what? The length of the vector will keep increasing. You're not coming closer to me. You're going away from me. Is that clear, everyone? They should be opposite to each other. That's where the minus sign comes here. That's your condition for collision. If your A relative is 0. If you have A relative, then velocity also changes. So you want to use this. All got this? This is a vector form for collisions. Clear, Arya?
Yes, sir.
Trishi, Sudiksha, Devanshi, Advait, Advai. Next thing. You can find routes. You can do that minimum distance. Matlab, then you have to find the equation of a line and then we have to use. Yes, you can do that. That will be too long. I can just use geometry and finish it off. Let's see the next one. Yeah, what you're saying, it can be done. This is another good question. Let's say this is a top view. You're seeing from a top, maybe a building or something. So there is a road here. The width of the road is 4 meters. It's a one-way road. So we have a bus here, which is coming in this road, which is exactly fitting the road. There is no gap. So we have a bus here. Bus ka width is also 4 meters, which is almost fitting here. And the bus is traveling with a speed of 4 meters per second. And you are standing here at a distance of 4 meters. I kept all 4 only. So the bus exactly fits here. You get in the scenario? So bus fits the road. You're standing at a distance of 4 meters. Bus is coming with 4 meters per second. Width of the road is 4 meters. Some reason you want to cross the road in a hurry. You don't want to wait for the bus, which is pretty dangerous. You should not be doing this. Wait for the bus to go. But some reason, right? You have to cross the road. So the question is, what is the minimum speed, right, of this person so that he crosses the road safely? Bus fits the road and moves with 4 meters per second. So boy at a distance of 4 meters walks or runs with speed u and crosses the road. Find u minimum so that he crosses the road safely. I want minimum speed. Huh? You go however you want, but I want you to go with the least speed. If you got an answer less than 30 seconds, you know you're wrong. Vanchika. I'll help you a bit. Did I ever say you should cross the road straight? I said minimum speed. You go however you want. Tell me one thing. If you are crossing the road, do you actually cross the road straight when the bus is coming like this? Don't you go something like this? Now try. I never said you should go in minimum distance. I want a minimum speed. You can take more time, but go with the minimum speed. Yeah, if he goes straight, then the answer is 4. You can go actually slower than that and still cross the road safely. The most common mistake is that people assume he is going straight, not necessary. How will you approach? Try. Shreyansh. 4 route to near area. You got even more than 4, na? You could have gone straight only. That would have been better. You got 4 route. You got even more speed. Now listen. First thing, the most common mistake. There is no reason why the man should go straight. So let the boy walk at an angle theta. So when he's crossing the road, let's assume this guy is actually walking like this. He's going with speed u at an angle theta. So if you look at the component, so this guy will be u cos theta. This will be u sin theta. Right? And the bus here is coming with 4 meters per second. So let's stop the bus. Let's solve with respect to the bus. Means we are seeing in the driver's ka perspective. So with respect to the bus, then what will happen? I have to subtract the bus ka velocity backward. So 4. So the bus will come to rest. So the driver will think, okay, I am at rest. Now this boy here, uska velocity will become vertical direction mein u cos theta. You stop the bus, so this will become 4 and this will become u sin theta. You have to put 4 backward, isn't it? Now let's see what happens. So if you take the bus, so this is the position of the boy. If you look at the velocity of him, so in the vertical direction, you have u cos theta. In the horizontal direction, you have 4 minus u sin theta. Now look at this. For different values of theta, I get different trajectories. So let's say if theta is a big value, then he will go like this. If you increase theta, or for different values of u, you get different positions. So for different u's will be this. It will be this. You're getting these all are different paths. These are different possible paths for different speeds. Think about it. If the boy ka speed is 0, what will happen? The bus will just come and hit him like this, isn't it? The bus will hit him straight like this. So if you increase the little speed, you will hit the bus here. If you increase little more speed, you'll hit the bus here. Little more, you'll hit the bus here. Little more, you'll hit the bus here. There is one particular velocity where you will just miss the bus. So if he goes with enough speed, there will be one particular trajectory here. where he will just miss the bus. He will just graze the bus and go off. So these are the different possible paths for different speeds. So the faster you go, the path will go higher and higher. This is what the driver will see. The driver will think the boy is coming at an angle. So this green line is the safest point. So this path, right? If this path is as seen by the bus, then the collision is avoided. You just miss the bus. Is the story clear, everyone? So if the boy is going with a different speed, starting from 0, 0.1, 0.2, 0.3, so on, if he keeps on increasing the speed, you will hit different positions. The first time you see the green line is the safest velocity. So that means you just want to avoid hitting the bus. So your velocity should be this way. Remember, this length is 4 meters. Remember, this length is also 4 meters. So this angle is 45 degrees. And you also have, this is u cos theta. And this thing is 4 minus u sine theta. So that also must be 45 degrees. So we have tan 45 is u cos theta by 4 minus u sine theta. Clear, everyone? In case you don't want to use relative velocity, you can still do that. Then what will you do? Let the boy go somewhere here. Let this point be some v. This is 4 meters. Let this be x. So how much will the bus travel? Bus will travel 4 plus x is equal to 4t. How much will the boy travel? This is u cos theta. This is u sine theta. The boy will travel x is equal to u sine theta t. And the vertical distance is 4 meters. So 4 meters is equal to u cos theta t. So you can eliminate t and you can do this. This also works. This is in the ground frame. Just forget about the relative velocity and do it in the ground frame. You're getting it? Let the boy go from here to here directly. The bus will travel all this distance. This is the bus ka equation. This will be the boy ka equation. You will get the same thing. So if you do all this, there you got an equation there. So tan 45 is 1 is u cos theta by 4 minus u sine theta. So from here, look at u is equal to 4 by sine theta plus cos theta. So what is this? This is the different minimum speeds for given thetas. So we don't know which angle the boy is going, right? So if the boy chooses different angles, you get different minimum speeds. These are the different minimum speeds for different angles. So if you go theta 30, you have a different minimum speed. If you go theta 40, you have a different minimum speed. Among all these angles, there is one angle which will give you the least minimum speed. So minimums may there is a minimum. So we need to minimize this function. And I hope you learned this in trigonometry. If you have a function a sine theta plus b cos theta, I can do maximum minimum also. Must be less than equal to root over a square plus b square. Remember this? That means sine theta plus cos theta ka maximum value is root 2. Therefore, to get the minimum speed, the denominator has to be maximum. So this will be 4 by root 2. Maximize this for minimum speed. This will be 2 root 2 meters per second. And you can clearly see here, this happens when angle is 45 degrees. So this boy must actually go at 45 degrees to the road. That will give the minimum speed. He can cross the road safely with this speed. Are you
So-
getting this in the form of relative? Yeah.
Sir, how will we know that 4 is greater than u sine theta?
4 is greater than u sine theta.
For the vector
Yeah,
to
it
be
is fine. Let
left
the signs
direction.
take care of it. Let the signs take care of it.
So we'll automatically get the value.
You will get it, huh? If you have taken u sine theta, that way you'll get theta 135.
Okay.
That will take care of it. But इसमें पता है ना, see, you're asking for minimum, so you should graze like this, right? If you take theta 4 plus u sine theta, that means the map boy will go like this. That is not minimum speed. So for minimum speed, you should be coming towards the bus. You should just miss the bus. All clear with this? But in case it doesn't strike relative motion and all, this thing is going, you can always do in the ground frame. If you solve this, you'll end up with 4 plus, put x here. How much is this? U sine theta t is equal to 4t. T is equal to 4 by u cos theta. Substitute here and substitute here. This will be 4. This will be u sine theta 4 by u cos theta. This will be 16 by u cos theta. Multiply this. You will get u cos theta plus u sine theta is equal to 4. You will get u is equal to 4 by sine theta plus cos theta. देखा same function आ गया without all the story of relative motion. So it's not like relative motion is always supreme. Sometimes you can get it easy also. Once you got this, हो गया ना, you got it till here directly. Maximum minimum, you'll get the answer. This also works. Are you clear with this? I could have done this in the ground frame. You could have done it in relative frame. It doesn't matter. All are same. You will get the answer. But if you do in the relative frame, this is how the path looks. So the driver will think the boy is coming towards the bus at an angle. Any doubts on this? Is this alternative method getting clear? If you do in the ground frame? Any doubts on this? Great. Next one. Next one, listen carefully. This is a little different. You should have seen this once. These are the kind of problems, you have a standard process. If you know the process, you'll get the answer. You don't know the process, you will not be able to do this. So there are certain problems in physics like that. This is one of them. So let's say we have a cat. These are called cat dog problems. Basically particles chasing and everything. So we have a cat here. This cat is going in a straight line with a constant speed. Let's call it u. At a particular distance here, we have a dog. The dog is chasing the cat with speed v. And how is this dog chasing the cat? It is always chasing, looking at the cat. So it is looking at the cat and going in that direction. So a cat is moving in a horizontal line. This is the top view. So both of them are on the ground. Obviously, they can't fly. So the cat is going with speed v. A dog is chasing the cat with speed v such that the dog's velocity is always directed towards the cat. That means the dog is always looking at the cat and running. Dog's velocity vector is always directed towards the cat. And v is greater than u. The speed of the dog is greater than u. Means this is what is happening. After some time, the cat will come here. So this dog is looking at this cat. So this thing will actually change direction. The dog is looking like this and it is running behind the cat. After some time, the cat comes here. The dog from here, again, it changes direction. It is going like this. Are you getting how is the dog chasing it? So it's kind of like this. As the cat is going like this, the dog will keep chasing like this. It is always looking at the cat. If the cat is here, it is looking here. If the cat is here, it is looking. If the cat is here, it is looking like this. It is getting closer and closer to the cat, and eventually, because the speed is more, it will catch the cat. Are you guys able to visualize this whole picture? How the dog is chasing the cat? So the first question: find the time when the dog catches the cat. Because v is greater than u, eventually dog will catch the cat. Initial distance between them is L. The second question: suppose if cat and dog ka speed is same, now the dog cannot catch the cat, but find the minimum distance between them. There are more variations you can ask. If the cat and dog are going with constant acceleration, or in this case, find the initial acceleration of the dog. So there are multiple things, but let's get these two first of all. Any variation of this question will be based on what we are going to do in case A and case B. Actually, case A is the standard question. B is something I changed. You can keep adding more to this. This question is from Merido, the first part. Find the time when the dog catches the cat. No, we don't know the trajectory. We can't calculate that. I hope that everyone the question is clear. The diagram is clear. What is happening and all. Hmm. Take a small break. Come back in 5 minutes. We'll continue from here. This will take time. By the time I finish off, I won't be able to give you a break. Take a small break. Come back in 5 minutes. But you can think about this in the meantime if you want. Nice one. Get the second part also. So how do we start this? Vx root v square. I think you guys know the answer, but how do we do this? Let's see. Get the second part. First one to standard tha. Second, how will you do? Other scans on. So let me help you with the first one. Like I said, you should have seen this before. It's the first time when you see this, it won't get an idea what is happening. So listen carefully. So we have our cat here. Cat is going in a straight line. So we have the dog here. This dog is actually going in some curved path. So at any instant, if you look at the dog, this is your dog ka velocity v. This is pointing towards the cat. Right. So at this instant, let the angle be theta. Remember, theta is variable. So every instant your theta is changing. So next moment the dog will come here. So this will go on like this, and eventually the cat and the dog, they will meet. If you look at the horizontal component, this is v cos theta. V is constant, but theta is variable. This is the horizontal component of the dog. Now, by the time when the cat catches the dog catches the cat, they both must have traveled the same horizontal distance, not the total distance. Huh? They must have covered same horizontal distance. How much is that? That we don't know, but we know it is the same horizontal distance. That much we know. Therefore, we can write, so this we are doing in the ground frame. So therefore, this horizontal distance traveled, remember the cat is going with speed u. This must be equal to u into t. this must be equal to integral v cos theta dt, because the dog ka speed is not constant. This is cat ka distance. This is the dog ka horizontal distance. Since the dog ka speed is changing every instant, we need to integrate, which is v cos theta dt. Now, unfortunately, I don't know dt, I don't know theta, I can't integrate this. So I somehow need to eliminate cos theta dt. So if you can eliminate cos theta dt, my job is done. Right, Ishwan. Is this part clear, everyone?
Sir,
Yeah.
when the dog catches the cat, why will they have covered the same horizontal distance? I didn't get that part.
Think about it.
Okay.
Now think about, see, there are only two options. It should be greater, it should be smaller, it should be equal. So if the dog goes ahead of the cat, did it catch it?
No.
If the cat
No.
is behind the dog, did it catch it?
Nah.
Then
Yeah, okay. Thank you, sir.
that's it. There are only three possibilities. Either you are ahead, you are behind, you are with me. If you are with me, then both must have covered this distance, and this distance must be same. I'm not saying total distance. I'm not saying this length is equal to this. The horizontal distance are equal. All clear with this page, everyone? Next thing. Now the second part of it. If you do with respect to the cat, now let's stop the cat. This is your dog. Now, if I stop the cat, look at cat ka velocity. So if I join the line between the cat and the dog, we saw this angle was theta. So this cat ka velocity will have two components. So this is u. This is also theta. This will be u cos theta. This will be u sine theta. And the dog ka velocity is v. So you're planning to stop the cat. So if you want to stop the cat, what should I do? I should subtract cat ka velocity from everyone. So if I stop the cat, so the cat will think, okay, I came to rest, I'm not moving anymore, but this stupid dog is coming towards me with v minus u cos theta. You have to subtract it. And it is also going in this direction with u sine theta. Isn't this what the cat will think about the dog? So here you're writing the components along the line joining the cat and the dog. So these are the components along and perpendicular line joining cat and dog. So this is what the cat will think. Cat will think dog has two components. One component is coming towards me and another component is at an u sine theta. So this is what the cat will see actually. So if you're standing on a cat and if you're looking at the dog, the path will look pretty weird actually. So we have v minus u cos theta. This is responsible for decreasing the distance between cat and dog. There, see, since I'm explaining you, I'm writing it as a big. In the exam, you won't take this much time. And this u sine theta is actually responsible for changing direction. This thing changes the angle direction actually. This is responsible for changing direction. Then, so this is what the cat will think of. The dog is coming like this. This is how the path will look. It's not a straight line. The cat will think the dog is coming in a curved motion. This is the path of the dog. Again, you really don't need all this stuff to solve the question. I'm just explaining as much detail as possible. That is how the path will look like. So if you're standing on the cat head and looking at the dog, this is what you will see. The dog is actually coming at an angle. So far clear? So the relative displacement, since you stopped the cat, the relative displacement will be integral v relative, remember the velocity is changing here, v relative into dt. What is relative displacement? Final minus initial, which is 0 minus L. Because when the cat catches the dog, that is your x final, is 0. Since the cat catches the dog, this is your x initial. This is so here dog catches the cat. So they both are meeting at the same place. So x final is 0. The relative displacement is 0. Is equal to what is v relative? V relative is this velocity, v minus u cos theta. Minus of v minus u cos theta into dt. Why minus sign? Because the velocity is decreasing. Negative sign since this velocity is responsible for decreasing the distance. Do you guys remember this? We used to write this before. If a particle is going like this, and if this is x, dx by dt is minus u, because x is decreasing when u is going towards the right side. Negative sign since distance between them is decreasing. There. So if you solve this, you'll end up with L is equal to integral v minus u cos theta dt. This is what I'm saying. Exam, you'll not do all this story. You'll directly write this step. Stop the cat, you'll get v minus u cos theta. V minus u cos theta dt is equal to L. Done. This is your second equation. Arya.
Sir, I didn't quite get the explanation you gave for which you took the x displacement, because it is also doing displacement along the y direction, right?
Well, let it be, no? Why do I care?
Sir, but the total displacement will not be L then.
What displacement you're talking about?
Sir, I mean,
You said you have a doubt in this. Suddenly don't mix up with something else. What is the
so
doubt in this?
no, I mean, you said that the velocity of cat is like this.
ठीक है.
Sorry, the dog. So it
ठीक है.
will be displacing along the x direction with L, right? But what about the y direction?
Arey God, this is L ray. What y direction, x direction? You're getting confused. Y is L.
Sorry, what about the x direction then?
So I don't know. They're equal. I'll ask you one thing. When the dog catches the cat, don't you think this distance and this distance are equal?
Yes.
And then what is the problem? So the horizontal distance traveled by the cat is equal to horizontal distance traveled by the dog. Which part of that you are getting confused?
Sir, but we have to take them in our equations, sir.
Which equations?
The one which you wrote,
This one.
the previous next page, sir.
Again, why are you getting confused? You said you have a problem in this page. What is the problem in this page? You said you have a problem in horizontal.
I didn't understand like why you took
No,
the
this page
displacement
is
to be
clear.
L.
This page is clear.
Yes.
वो बोलो ना. You said horizontal. Now don't talk about something else. Now why did I take L? This is relative displacement. Initially, what is the position between cat and dog?
L.
L. Finally, when the dog catches the cat, what is the distance between them?
0.
So what is x final?
Oh, okay, now it is.
Say that na. You started the whole doubt with horizontal y. Then you started saying, what is this? Don't mix up two things. Is this clear, everyone? The two equations. Again, listen, how did I get both the equations? If this comes in the exam, this is what I will do. Cat is there, going straight. Dog is there, it is chasing here. Velocity is v, angle theta. So this cat will travel ut, this dog will travel ut is equal to integral v cos theta dt. One step. Second part, stop the cat, dog is there. Dog is going with v, cat is going with you. This angle theta, this angle theta. So this components will be u cos theta, u sin theta. If I stop the cat will think dog is coming towards it with v minus u cos theta. This is u sin theta, which is useless for me. So this velocity is responsible for decreasing the distance between them. What is the distance between them? L. What is the speed? V minus u cos theta into dt. Why? You have to integrate because the speed is not constant. There, I got my two equations. Are you getting this? If this is the exam, this is how you'll write the equations pretty fast in a minute or two. And this thing, you should know that you have to do like this. Unfortunately, there is no way you will figure it out in the exam. If something like this comes, this is the only way to approach. At least till now, I couldn't figure out a second way. So if you don't know this process, you're done with the question. Exam May, there is no way you'll get an idea. You will waste your time 10-15 minutes. You should just leave it and go ahead if this doesn't, you don't remember this. So one horizontal, one relative. And every other situation that I give you in this model will be like this only. They'll start from here. So there we got the two equations, which is ut is integral v cos theta dt. Remember, I don't know theta, I don't know dt. The second was L is equal to integral v minus u cos theta dt. So this is ut, v is anyway constant, so I get integral cos theta dt. So this is L, this is vt minus u integral cos theta dt. So take this cos theta dt, which is ut by v, and take it and substitute here. There you eliminated cos theta dt. This will become u square t by v. So we get L is equal to v square minus u square into t by v. We get time is equal to vl by v square minus u square. This is the time when they meet. But this is what is happening with the whole motion here. The cat will think dog is coming like this. This is happening in the ground frame. Here, if you want, you can write vertical also. Integral v sine theta dt is equal to L, but this is useless. You can't use this anywhere. Are the steps clear, everyone? So first thing what we did, the cat and the dog ka horizontal distance is equal. Second thing we did, we stopped the cat, and then the cat started seeing the dog is coming with v minus u cos theta towards it. The u sine theta is useless. So that v minus u cos theta is actually decreasing the distance L. So if you write it mathematically, you should write like this. But in the exam, you can simply say L is equal to v minus u cos theta dt. It works. You get two equations. It's a matter of solving. All got the steps. Keep this problem in mind. When we have a kinematics ka some advanced test, in some test, I'm definitely going to ask this. I'm revealing the paper also. In that, I'll do some modifications also. Question अभी तक हुआ नहीं. Second part में क्या करेंगे? If v is equal to u, then what is the minimum distance between them? Now what will change in the problem? Now can you think of, I'll give you a minute or two. Story is still the same. So you still have to follow the same steps, but now you'll understand what will change. If both of them have same speeds, the dog cannot catch the cat. Let's see. Now again, draw the picture. So if you do this thing, v is equal to u. Now what is happening? Same story, the dog is still chasing the cat. But unfortunately, it can't catch it anymore. So the cat will be like this, and eventually this dog will be like this. So at this instant, the dog is going with you, cat is also going with you. This instant, the distance becomes x. You can't change this anymore. Agreed? This is going with you, this guy is also going with you. This angle is theta. So the question was this, find x. So eventually, after a long time, both the cat and the dog will be on a straight line and both are running with the same speed. At this point, the distance cannot change anymore. So if you take the horizontal distance traveled by the cat, that will be u into t. The horizontal distance by the dog, that will be integral v cos theta dt. Till here, the story is the same. But the difference is the cat is traveling more ut minus integral. This is also u cos theta only. Integral u cos theta dt will be equal to x. This is equation 1. Previously, these two used to be equal. Now they're not equal. Next, what? The second part, stop the cat. That story is always there. So when the cat is here, this dog is chasing the cat. So let's stop the cat. So this is going with u. This is also theta. So this component is u cos theta. This is u sin theta. The dog is also going towards you. So if you stop the cat will think, okay, I came to rest. But this dog is coming towards me with the velocity u minus u cos theta. This is u sin theta. The relative displacement is v relative into dt. So story is the same. Now you tell me, what is the final distance between them? Finally, what is the distance between them? X. What is the initial distance between them? L. What is v relative between them? Minus of u minus u cos theta. Why minus? Because the velocity is decreasing the distance. This will be L minus x is equal to integral u minus u cos theta dt. If you had forgotten minus sign, previous problem would have still worked, but now you'll have an issue. This is your second equation. So in the previous problem, previous part, the x final was 0, x initial was L. Now x final is not 0, x final is x. That is a final distance between them. There we are done. We got two equations. This comes from the horizontal distance. And this comes from relative. So let's solve them. So ut minus integral u cos theta dt is equal to x. The second thing is L minus X is integral U cos theta dt. So yeah, you can substitute here. So this will be ut minus L minus X U minus U cos theta. This is there. This is your second equation. This will be U integral cos theta dt will be ut minus X. So take this and substitute here. We get L minus X is ut plus ut. Yeah, that's a minus sign, right? Minus ut minus X. L minus X, ut cancels, we get X. X is equal to L by 2. There. All got this thing. So the final distance between them is L by 2. If they both have the same speed, the cat will get closer and closer to the dog, but this is the thing.
Could you go to the previous slide for a second?
Clear with this? There. So you can play more on this thing. Definitely sit with this and spend some time and do it. I know it looks confusing, but frankly speaking, yeah, atta marne. You should know the steps. You see cat and dog, you should know I do need to this, I need to do this. This is a kind of problem, where there's really not much to think. You know the process, you'll get the answer, or else you're stuck. So the first one, right? The first part is actually a Erido problem. Second part, I modified it. If V is equal to U, what happens? You can do such things. But all got an idea here what is happening. So the best thing to do is tomorrow, today class gets over, tomorrow take a rough paper, sit with the question and try to do. You will not get it mostly. That is completely fine. Struggle for some time, 4 or 5 minutes, and then again see the solution. So that struggling is important. When you're struggling, right, you're forming new connections in your brain. So when something like this comes in the exam, you'll be able to replicate it. But if you just flip the pages like this, na notes mein, okay, I understood. Okay, I understood. Okay, nothing you understood. When the same question comes in the exam, nothing will be there in the head. So if the same question comes in the exam, I can even do more. So this cat is going with U. The dog here is going with V. This is L. So this is going in a line, and we saw this thing is bending here. Now see, the dog is going with constant velocity, but the direction is changing. If a particle ka direction is changing, that means there's an acceleration. So I can ask you like this. Find the initial acceleration of the dog at t0 basically. We can't find somewhere else, it becomes too difficult, but initial acceleration you can figure out. How will you do that? So initially dog is like this, after some time dog is going like this. The mean velocity vector has changed. So what is the initial acceleration of the dog? How will we approach this? Listen, again, this is a little weird. Since you're asking initially, right, you're talking almost at t0. Let's say in small time dt. Now, these are the questions, right? Frankly speaking, you'll not get an idea. You should have seen these techniques before. And that's the whole point of the class. You are learning these things. So in a very small time dt, the cat will travel how much? U into dt. It has traveled a small distance. During this time, what did your dog do? The dog, which was looking at the cat straight, suddenly now starts looking like this at an angle. This is also v, this is also v, this is angle theta. Make sense? Isn't that what the dog did? Dog simply changed its direction. It is head from straight to little to the right. So if you look at the Docker perspective, this is your initial vector v initial. In small time dt, the Docker had rotated v final. Theta is very small, so I can almost assume it to be a line. This will be a change in velocity vector, delta v bar, v final minus v initial. V final vector minus v initial vector. This comes from triangle law. V initial plus delta v is v final. Since theta is very small, we can treat it like an arc. We can treat delta v is an arc of radius v. And angle theta. That means you're treating this thing like that is the whole advantage of dt terms. So this is v, this is v, this is theta. So this thing will be v d theta. And you're saying this is also equal to delta v. So delta v is equal to v d theta. Divide both the sides by time. So delta v by delta t, which is small dt, will be v d theta by dt. Delta v by delta t becomes acceleration. What about d theta by dt? Again, here from you can clearly see tan theta is opposite side ut by the L, the opposite side by L here. For small angles, I can treat this thing as theta because the angles are small. For small theta, tan theta is approximately to sine theta is approximately to theta. Perfect. So we got theta here. So d theta by dt is u by L. So this is v u by L. This is the acceleration of the dog at t0. V is the velocity of the dog, u is the velocity of the cat, and L is the length between them. So take this from here and substitute here. Too many approximations, but yeah. Yeah.
Sir, I don't know if my method is correct or not. What I've did is that I've taken,
Did you get the same answer?
yes, but I don't know if it's a coincidence or not.
You have to
Last
send a
time.
photograph. We'll see after that class.
Oh,
But is this clear, everyone? There, you can see how much I can play around with this question. There is more we can do. We'll see later on. You got the hang of it. These are some of the tough ones in relative. Let's see one more. So in relative motion, right, it is all not always, Rain Man. There are the problems like Rain Man and the Riverboat. Those are actually the easier ones. Those are some standard models. These are different. So definitely go through this, check it out. This acceleration of the dog is also different. You can only find it initial. After some time, you can't find because the distances will change. I don't know how to do that. The next one is another standard model, which can be asked in mains. Advanced where they can ask really good ones, but I need circular motion for that. So we'll see this again in circular motion. So look at this thing. You must have seen this anyway. So we have three particles, A, B, C. So we have an equilateral triangle of side A. So these three particles are going such that A is chasing B with speed u, B is chasing C with speed u, C is chasing C with speed u. So the particles are chasing with each other. A, B, C are moving such that A chases B. What do you mean by chasing? That is, velocity of A is pointing towards B, just like the cat and dog. B chases C, C chases A. Let me show you how it will look. So this is A, this is B, this is C. So what happens? The moment B goes a little forward, A will take a turn. Because A took a turn, C will take a turn. Because C took a turn, B will take a turn. You're getting what is happening. Everyone is chasing everyone else. So this things right will start going like this. At any instant, if you try to join them, you will get an equilateral triangle. Next moment, this will come here, this will come here, this will come here. So you'll get one more triangle like this. So let me show you a good picture. There, this is how they will look. So if this is A is going like this. This is B, B is going like this. I think I'll draw on it. It depends, meaning I think these velocities are given in the opposite direction. This is U, this is U. B is chasing A and C is chasing C. So they came in the reverse. So this is going like this. You're getting how it is? They're spiraling inside each other. This is how the path will look. In my case, A is going up. In this case, A is going right. So they will look little different spirals, but yeah, the paths look like this. So what do you notice in this? While they're rotating, you can clearly see, if you look at any one path, this is actually spiraling in. So there are a few observations here. First thing we'll observe, this A, B, C will always form an equilateral triangle. Because of symmetry, they're going with the same speeds and they're on a symmetrical thing. They always form an equilateral triangle, which is shrinking and which is also rotating. So this triangle is shrinking and rotating. By symmetry. If they don't have same speed, this wouldn't have happened. And eventually what will happen? By symmetry, they will meet at the centroid. You can look at the picture here. This will always form a triangle, 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 triangle. Is the scenario clear, everyone now? So now the question, find the time when they meet. Again, if you just want to solve the question, it will take 30 seconds. But let's try to understand the whole thing, because this will again come in circular motion. Find distance traveled by A till they meet. How will we approach this? Later on, we will see. We can do the same question for 4 particles chasing. You know, how will 4 particles chasing look like? If 4 particles are chasing, they will look like this. It's a square. You can even extend this further. If you have 6 particles chasing, it will look like this, an hexagon. These are 4 particles on a square chasing each other. This is 6 particles in hexagon chasing each other. So they will always form an hexagon which is rotating and shrinking. Idea is the same. Think for a minute, how will we approach this? Once you got that idea, it is pretty easy to solve. Right हो गया. Let me help you with this. You try that hexagon thing, I'll show you. Remember, the main story is here. The particles will always form an equatorial triangle. Okay? So, listen to this. Initially, when the triangle is like this, so this point A is going with speed u. Great. B is going with speed u. C is going with speed u. Listen carefully. This is the idea for the problem later on also. This is your centroid. And this angle is 30 degrees. So if you resolve the velocity into components, you'll get u cos 30, and this will be u sin 30. Similarly, if I do the same thing for B, this will be u cos 30, and this will be u sin 30. Similarly, u sin 30 here and u cos 30. Now, if you notice this, after some time, when this triangle is rotating, remember it is shrinking and rotating. If you do the same thing, you will still notice the velocity towards the center is u cos 30. This is still u sin 30 because the angles are always same. U cos 30, u sin 30. When you're seeing this, can you see something? What is happening? How are the velocities looking? The two velocities are doing two things. What is u cos 30 doing? U cos 30 is responsible for shrinking the triangle, isn't it? You can clearly see here, u cos 30s are responsible for bringing them closer and closer. No matter how much the triangle rotates, the velocity towards the centroid is always u cos 30. U cos 30 is responsible for particles to meet. So this is what is shrinking the triangle. What is u sin 30 doing? U sin 30 is rotating the triangle. Can you see how these velocities are? Tangential, right? That is making the triangle rotate. So the two velocities are playing two roles. Right now, we will not use u sin 30. We will use that in circular motion. U sin 30 rotates the triangle. There. Now, when you see the shape, can you get it why these things are rotating and they're shrinking? So one velocity is taking you toward the center and one velocity is making you rotate. That's why you're getting a triangle which is rotating and shrinking. Is this understood? Right? Now, if that is understood, then you're done actually. That means when you take this, you're going from A to O. What is the distance from A to O? So the time taken to go from A to O. So this particle, right, if you actually draw the trajectory, it looks like this. This is how it goes. This is the path of A. And you will notice at every instant, the velocity toward the center this is your centroid. The velocity is u cos 30, meaning no matter how much you rotate, the velocity is u cos 30. The velocity is u cos 30. So we are always going towards the center with u cos 30. Therefore, the time taken to go from O to A will be nothing but the length OA by speed V along OA. Do you agree with this statement here? If you're going from O to A, then I'll take the distance O to A and I'll take the speed along O to A. So in a centroid, what is the length OA? Anyone remembers?
A by root.
Yeah. In a centroid, this height will be how much? It divides in the ratio of 2:1. So that will be 2h by 3. Root 3 a by 2. So a by root 3. So this will be a by root 3. What is velocity along OA? U cos 30. U cos 30 is how much? U root 3 by 2. You're done. So the answer is 2a by 3. What is the distance traveled by A? Distance is nothing but speed into time. So this particle A is traveling with speed u for this much time. So distance traveled by A will be simply speed u into time. So that will be 2a by 3. So this spiral ka thing which I am drawing, the length of this entire spiral is 2a by 3. Is this making sense? Did you get the concept here? This is the main idea. This understood everyone. So when you're going towards the center, there are two velocities. One is making you go towards the center, one is making it rotate. So if you're going towards the center, you're interested in this distance by that speed should give you the time, isn't it? Is that clear, everyone? So once you got the time, the distance traveled by the particle is nothing but speed of the particle into time. Everyone clear with the steps? So using the same logic, can you do it for the square? So if there are 4 particles going on a square, side L, this is going with you, this is going with you. Can you tell me what will be the time for this? Same thing, if you have an hexagon, if you have 6 particles going with you, chasing each other, same story. What will be the time for this? Again, remember the story. We know they're going to meet in the center. So resolve the velocities towards the center, perpendicular to the center. The velocity towards the center is responsible to take you towards the center. So for a square, this is the center. What is this angle? 45. So what is this component? U cos 45. What is this component? U sin 45. You can clearly see. This component, U cos 45. This component, U sin 45. The U cos 45s are bringing you closer and U sin 45s are rotating you. Therefore, time taken will be, so this is point A. So time will be O to A by U cos 45. O to A is nothing but half diagonal L by root 2. U cos 45 is L by root 2. L by U. Easy? Right over here. Get the hexagon. Understood? That's how you do. Let me give you any number of particles. This is the story. That's what I said. If you know what is happening, you will solve this in less than a minute. So when you resolve the velocities, you'll have two components. One will take you towards center and one will make you rotate. Since you want to meet, take the guy who is going towards the center and you're done. What about the hexagon? 12 by U. How we are right. Right, Samyak. Try. 30 seconds. Right, Arya. There, this is the center. So if you put this thing, this angle is 60 degrees. So you're going toward the center with u cos 60. You're rotating with u sin 60. Therefore, time will be O2A by u cos 60. In an hexagon, you know, the sides will be all equal to A. This will be A by u by 2, which is 2A by. Are these questions clear, everyone? Particles facing each other. There. So this will help you understand what each component is trying to do. One is trying to get you closer and one is trying to make you rotate. Any doubts on this? So there, that's a bit about relative motion. These are non-standard ones. This is a standard problem for me, so you can do with any number of things. So what we did today, I know it is a little heavy, but make sure to go through the whole stuff, especially this cat dog thing. This one, there's a lot of stuff there. All are important models, so definitely check it out. These all are really advanced problems. So next class, when we catch up, we'll continue with this. We are going to do the standard ones, the Rainman, Riverboat. These are standard ones which are at a mains level and all. Quite important, right? So next class, mostly we'll be doing that part. So relative motion, I think mostly next class we should be able to wrap up the next class relative motion. After that, we still have graphs. Kinematics is a little big chapter. So, okay. So we have almost done how many questions? 62. So yeah, that itself is a big, huge collection of questions. So make sure to go through them. Okay. With that, we'll wrap up for the day. And remember, there's a test online, so make sure to give. Thursday night, 11:30 is the deadline. So any doubts in the class notes? Anything you can stay back and ask, or else you're free to leave. So take care. Stay safe.